So I think we're going to start by setting up this architecture first. So we're going to get this set up first. Then we start getting the input data maybe from Python and loading that into our architecture directly. So what I'm going to do is going to launch up my IDE and create a new project. So I'm just going to drag a new project in there and we can start. Now, this new project doesn't have to be with PyCharm. That is currently my IDE and the IDE that I'm currently using, but you can use any IDE of your choice, maybe Visual Studio Code or any IDE of your choice, whatever it is, yeah, and even if it is just a text editor. All right, so the only thing you just need to do is get your virtual environment so you can get the installation requirements into the system. Okay, so now basically I'm just going to call this what should I call it? Call this Lakehouse engineering. Okay, Lakehouse engineering seems fine and fancy. Okay, so I'm leaving it as a virtual environment, and I'm going to change this to 3.9 if that is fine. This is 3.12. I think I'll just use the 3.9.13, right? For some reason I have strong preference for 3.9. You can call me a cake or something, but it looks like for the latest versions not all of the packages are fully compatible, so I want to prevent issues where I run into dependency problems and I wouldn't know exactly quickly how to quickly fix that. Okay. Okay, something is asking me to install the package. Okay, that should be fine. Yep, so it's doing the installation now, and in a few seconds, yeah, if you're doing this for the first time, I mean, you may not experience something like this if you're using your virtual environment or you already have the installed version on your machine. So I was using 3.12 before, but for some reason I don't want you to experience maybe similar challenges that I had, so that's why I'm switching to 3.9. So okay, so I think that's pretty much stable if you ask me, and most libraries are fully compatible with this version of Python. Okay, so going to the terminal, once that is said, I'm going to just touch my main.py. Yeah, main.py is fine. We need that, and we need one other thing, the Docker Compose that will host the architecture. Docker compose.yaml. Okay, now so I'll just let me increase this a little bit to size 15. Is that right? Yeah, 15 seems okay, and once this 15 is fine. Yeah. So basically, looking at our architecture, if you look at this, we are going to have different sections of the system. So we're going to start with the Minio, where we set up that on Docker, and we have Kafka in KRaft mode. So basically, Apache Zookeeper works just fine, but it's deprecated now, and I think the community is dropping support for that. So it is best we switched to the latest version, which is the KRaft mode, and the reason is simple and understandable, because if you have Zookeeper hosting multiple brokers, what that means is you have a single point of failure. So if Zookeeper goes down, all your brokers goes down with it, right? Because it's the one coordinating all the activities of the broker. Now that makes sense with KRaft mode, and that solves the problem, because individual more like have a tiny Zookeeper in them, and they can exist independently of others, even though they're in the same quorum. Okay, and the quorum is more where you have multiple brokers and controllers working together. Okay, so in this case, we're going to have the KRaft mode. Each of the brokers that we're going to be working with are going to be executing or existing in silo while maintaining their quorum membership. Okay, so coming back to this, we are going to have our controller here, and so each of these brokers will function as a broker as well as a controller. So that's fine. So we don't have to have separate controller and separate brokers. So if you want, you can separate that, but in my case, I'll just use the same for as the broker as well as the controllers themselves. So yeah, so let's quickly set that up and go into that. Okay, so the first thing we want to do is I'll just come back to this main later. But what I want to do basically is to have my services. So the services that we want to use, we're starting with the broker one. I'll just switch off this auto completion, disable auto completion. Okay, so I'm going to have broker one, and that would be an image that is coming from Confluent Inc. CP server. Now, if you're using CP Kafka, you have to be careful. If you're using CP Kafka and you want to use the control center, you might have to have some dependencies for maybe like something like Confluent Metrics Reporter. But if you're using CP server, that is kind of inbuilt, so you don't have to specifically have the jar dependency. I think that would make more sense when we get to that point. Okay. Yeah. So I have CP server and I have container name, which is going to be the name of this particular container will be broker one. Then the host name is going to be broker one as well. The port that this is going to be working on is going to be exposing 9092 to the outside world, and everybody can access that. So in the environment, we're going to have Kafka node ID, and that will give us the first, because this is broker one and their Kafka node ID only makes sense to be one as well. Okay. Then for our Kafka listeners, we're going to have the internal, and that would be broker one, and we're going to be exposing that as 29092, and we have controller would be broker one and 29093. Yep. And finally the external listener, and that would be on all ports available and 9092. Okay, so to double check that, internal, controller, and external. Okay, good. Then we have Kafka advertised listeners. Okay, and that would be more like the same, isn't it? I'll just maybe get this without the controller, so I'll just remove the controller from here. We just have the internal and the external. Okay, good. And finally, we just have metrics reporter and Confluent metrics, Confluent metrics reporter bootstrap server is going to be broker 1299092. Okay, so the rest is going to be, if we have maybe broker 2 now, we can just get that in. Yeah, we get that in as well, and this will be broker 2, and this will also be 9092, but instead of the port of 9092, because that is taken right now, that will be 9093, and the node ID will be 2 in this case. We have 2 brokers now, 9092, 9093, and we're exposing 9093. Okay, the advertised listener is going to change to 9093 as well, and this will be broker 2. Good. Now you may ask me, where are the other properties? So the reason why I'm trying to limit this is because individual properties, I'm trying to apply the principle of don't repeat yourself, the dry methodology. So that makes sense, because now these are the major things that are different, so the rest is just common attributes for these 2 brokers. Okay, so I'll just use that and put that as my common attributes. Okay, so I'll just come up here in the services section, just up here, I'll just have my X common environment, and that would be my ampersand common env, and I can just it's a lot to type in, so I'll just maybe copy paste that and just talk through that. Okay, so we have our control listener name, the security protocol map, the broker listener name as well, then the quorums. Now this is where we specify the number of people in the quorum. So in this case we have two people, two broker, not people. So the first one is the broker 1 and broker 2, and they are listening on 2092 and 2093. Okay, so I'm exposing 29093 here as my broker 1, so I can listen on that as my quorum voter. So that's fine. Now interestingly, we have the process rule. This is where it is important. So if you are using one as controller, the other one as broker, you have to specify separate process rules for them. But in this case, I'm using both as the broker as well as the controller. Okay, you can check the documentation for detailed information about that too. So we have the rebalance delay milliseconds and the replication factor. Now in this case, I'm having two brokers and controllers, so I'm using the same replication factor. The cluster ID, you can use any base 64 for this, so I just use this from there. And the Kafka log directory, I'm using the combined log, which is fine. Then this is what I'm talking about. If you're using CP Kafka, for instance, as your image here, you will not have this supported by default out of box, so you might have to use the CP server in that place. Now for the metrics reporter replicas, you can use 2 because we have 2, or you can leave it at 1, it's fine, it doesn't really matter. So excuse me. Then you have the Confluent metrics enabled, which is true, so we can see the details about the brokers on the UI, or the broker information like the production, the consumption and stuff like that. We can see that on the controls in the control center. And the customer ID here is anonymous, so it's fine. So it's not going to be sending out anything particular to everybody. Okay, and finally, since we have the common environment, it's good to have the common health check. Okay, so I'm going to have x common health check because of the dependencies. If you look at our architecture, so control center and schema registry are directly dependent on this Kafka broker, so it only makes sense to have our health check, so we can know when the brokers are available and we can reliably send messages to them. Okay, the interval is going to be 10 seconds, the timeout is going to be 5 seconds, and the retries, which is the number of retries, is just going to be 5. So it tries it every 10 seconds for 5 seconds. If it fails, you try it for 5 more times, and if that fails, then the broker is unhealthy, so that's fine. Now let's get in this information in here. So we just do the full here and get in our common env, and finally we do the same for our node 2 as well, and that will be common env. Good. Now the final thing we need to add here is the health check, which is going to be what we have here as the common health check. So I'll just copy this and replace this, and that would give me asterisk of common health check. Okay, so I'm going to have a test, so which is going to be the command to be run, and because the command is going to be different on different ports, so I'm going to have the cmd and it's going to be bash. Maybe I'll use the full quotes, shouldn't be that different, but I'll use the full quotes. Okay, then -c, just echo are you okay. So are you okay? If I'm able to see are you okay and the server responds to me, then it's fine. Localhost 9092. I'll just replicate the same thing for the broker 2 as well. Maybe I'll just reduce this a little bit. Okay, and in the health check, I'll just copy that and paste it here. Okay, so instead of 9092, this will be 9093. Good. And the only thing that is left is the networks where this is going to be sitting in. So I have my test now. I just need to get my networks. The networks is going to be data mastery lab. Okay, so I'll just copy this and put that in my, yeah, I'll just copy that and put that in the second broker as well. Good. And finally, we just bring in our networks, and that would be data mastery lab. Good. And that's all we have to do to set up our two brokers. Now, if we start this off, this is going to start up in KRaft mode. Okay, but for us to see that in action, let's bring in our control center and we can see how that looks like. So I'm going to just copy paste the control center. So where is it? Broker 2. Okay, and here I'll just paste that here. So what that means is simply we have the image of CP Enterprise Control Center. The host name and the container name is Control Center, and this is depending on the schema registry. We don't need that for now. I'll just I'll leave that as it is for now, and 9092, and it's going to be on this broker Bootstrap server. We're going to enable the schema registry back once we are done, but for now this is going to be Confluent, not Confluent. Okay, and yeah, the health check is here as well for the control center, so we can see what is going on the UI. So I can just do, once this is done, docker compose up in detached mode. So if you don't have the image will get pulled down to your system from the cloud, which is the Docker hub. But if you have it, it's just going to automatically start it. So I think it's purely routine in this case, so it's fine. So if you look at our Lakehouse engineering on the UI, something is going wrong here. It says exception, advertised listener cannot use non-routable this. So something is wrong with our advertised listener in there. So let's go back. What's in our advertised listener? I must have typed in so the external, instead of here it should be localhost. Okay, and I'll just replace this guy as well and start this up again. Hopefully that should fix it. Yep, I think it is fixing that. And if you check broker 1, yeah, it's starting up and everything is looking all green. So we just wait a few seconds for the system to be done and we can check it out. Okay, and the control center is still, I think it's trying to link up to the brokers available. So the cluster ID has been established and it's assigned this, so it's fine. I think we can check hopefully on the in the UI now. If I check this out, okay, it's still not coming up yet, so we'll just wait a few more seconds for that to be done. Okay, I think I think at this point the brokers and the broker 1 and 2 is fine, and let's just check if the schema registry is able to pick that up now. And is there anything here? Yeah, it started up now. I think it should be able to receive now because it did a HTTP GET request, so that's fine. The control center as well, is that fine now? Good. So the control center as well is running, up and running, and everything should be fine. So if we check, it started the server already, and let's check on the UI what is going on the broker. Good. So our control center is up and running, and you can see we have one LD cluster and we have 2 brokers. Now 2 brokers in this case, all the other informations are just by default, so things to get the system up and running. So if you check the broker, we have the KRaft leader in the KRaft mode now. So it's like it's specifying this as my the first broker, which is the broker ID 1 with the node ID 1, right? And it's inside the metadata quorum, which is good. So that means our quorum is fine and our 2 brokers are working hand in hand to service the requests that are coming into the system. And you can see the different information about the the latency of production, as well as the fetching, which is probably the consumption in this case. Okay, so there is no topic in the cluster in each of the brokers except the internal topics, of course. So yeah, we're not using any of the other information here. So but yeah, so technically our brokers are fine. And if you look at the architecture we currently have right now, so this part is potentially taken care of. So what we need to do now is set up our Minio, as well as Apache Spark, maybe Flink as well, everything to be able to do everything else on our system. Okay, so let's proceed with the Minio section. In the last section, we talked about and we established our brokers and the schema registry and control center. And right now, all of them are working as expected. And you can see on the UI, the KRaft information and the metadata quorum, where we have the KRaft connected to each of the brokers that are existing in the quorum. Okay, and you can see the information here. Good. Now let's start with the Minio for the services that we're going to be working with, which is the S3 drop-in replacement. Okay, now going back to our services here, we are done with this part, so I can just come back here and get in our Minio. So I'll call this Minio or Minio. So the host name is going to be Minio, and the image would be Minio. Good. The container name is going to be Minio as well. So maybe this should go up so we can have these two following each other. So the ports that we are exposing this on is port 9090. Sorry, 9000 rather, 9000. And we're exposing on 9001. So if you want to access the API, I think it's on 9001, I believe, and 9000 for the UI, which is the web server. Okay, so the environments in this case would be Minio root user, which is going to be Minio admin, and the password. So yeah, you need to apply the best practices here, so you can put this in an environment variable, or you hash it as well, regardless of how you do it. So you need to just Minio admin, you need to apply the best practices to that. So in this case, we are using this on my development environment, so there's nothing really too risky at risk here. So the command in my case would be a server. So we just have the data, and we just have console address. It's going to be 9001. So that will be the console address. Now simple as that, we just have networks as well, and we can just bring in data mastery lab as our network, just like we did for our control center, which is here. Okay, I'll just copy that. I think I was doing this wrongly. Good. Now this is in the now we have the Minio S3 potentially, but we still haven't set up the commands to create the right buckets or the right dependencies, maybe the ACL access control list. If we haven't done that, we can do those on the UI, but it may not be as efficient. So let me show you how to do it from the background, in the background, so you don't have to potentially do this manually on the UI, even though it works just fine when you do it on the UI as well. So we have the initialization. So I'll call this MC init, and here we're going to have the image. So the image you're going to be using is called the MC. So Minio allows you to use the command, so which is the MC. So the command container name will be MC init, and the entry point in this case, which will be the commands to be executed when you run this particular image this Docker service. Okay, so we're going to go into the bin bash, and we have a command which is going to be the command to run. So we just sleep for a few seconds, and the reason for that is to just quickly wait for the initialization to be done before running the command. So we go into the user section, okay, yeah, user directory, and we have the bin MC, and we can configure the server that we just created. So we are configuring it quietly, and the host is going to be, we're adding the DML minio, and this is going to be on HTTP minio 9000. Okay, so what that means is this host in particular is named DML minio, and it's going to be exposing its services on 9000, port 9000. Okay, and the username and password is minio admin, and the password is minio admin. Okay, so that is done for this part. So the other part is to create a bucket. So we are creating a bucket right now, and we're creating this bucket, not quite, it's quiet, DML minio, and that would be, I'll call this maybe bronze. Okay, you can call it whatever you like. I'll do the same again, and that will be the admin, and this is where we want to maybe link this to the events that will be happening. But I think we don't have to do this on the terminal. We can do this on the UI just fine, but if you like, you can configure this on in the terminal as well. So I'll just leave this as it is. Okay, so I'll just have service restart, and DML minio. Okay, so to go through this again, what we've done so far, I'll just close this command. Okay, so we just say we have a configuration, expose this host on this port with this username and the password, and we are creating a bucket, which is the make bucket. Okay, and it's called DML minio. This is our host, and this is the bucket we are creating, just like creating a new S3 bucket on S3 on AWS S3. Okay, then we have this, we have to restart the host, which is the host that we created here. The final thing is the dependency. So we just have to have a dependency. So we have depends on, we have minio. Okay, and the network this is going to be sitting in is going to be data mastery lab. Okay, I think that's the only thing we need to do here, and we are done with the minio and the minio initialization. So let's start this up and see how that looks like on the UI. Okay, we wait a few seconds. So this is just going to be running one time mode, and it shuts down after running. So it shouldn't stay up forever. So if you look at this, you just have DML minio has been successfully added, and the bucket has been created successfully. So you just restarted the server, and the server now is up and running. Good. So right now the server, we can check it out, and you can check the server here, and you should be able to see it on this port of 9001, and I have minio admin, and if you log in, it looks like this. So if you like the light mode, the light mode looks like this, and the dark mode looks like this, which is for ninjas. Okay, so we have the bronze, but there's nothing in here. Then the access key, just like you have on AWS users, so we can have access key and secret keys. If you want to read the documentation, you can go to this part, and you can see the object storage and the details here. I'll leave that as it is for you to go through. Then for the bucket, so this is where you configure the event, more like the backend, the event, the replication, the life cycle, access, and maybe if you want to allow anonymous access to it. The policies are here as well. The identities, user, LDAP configuration will be here. Then the monitoring for the metrics, the logs, the audits, and stuff like that. You can see everything here as well. These are the events that are currently added. So if you want to have something like Lambda events here, which is what will be useful for us in this case, so we're using AWS Lambda here. So that would be, this will be replacing that for us. And if you have tiering, which is the more like the lifecycle management, you can do that here. Maybe tier 1, tier 2 or something like that. So if you want to replicate this across multiple sites, you can do that. And simple configurations like the region, the compression, the API information, scanner, and the rest of this information, you can easily configure them. But we're not focusing so much on that. Oh, by the way, the license information is AGPL license. So you use this. So you might want to, read the details of the AGPL license and how you can use it if you eventually decided to use this for your enterprise project. Okay, so if you're using this, you need to read this license information so you know what you're going into, and probably if there are going to be any licensing fee or something like that, just read the license and you get the right information from there. Okay, so once that is done, yeah, you can see the licensing information here. So I'll just leave that as it is. Okay, so now once this is done, we are good to go, and we can set up the rest of the architecture we are going to be working with. So potentially this is taken care of. This is taken care of as well. So we have a bronze storage that we can write into now. Maybe it's time we start writing into it and we can see what's going on. Okay, so in this bronze, what I'm going to do is just pull in all our data into this. Okay, so to put this into context, what I'm trying to do is I'm going to pull in all these records of taxi from New York. Okay, so I'm going to get all of them, about 3 million records for a single paquet file in a single month. So for other months, it could be longer, it could be, more than that, but I'll just pick one for now. We can, use that to, so I'll read that line by line and push that as a single JSON, which we can now use in our Kafka. Okay, that will be a little bit more clearer by the time we go into it. But once you have the file, we read the file from this bronze, and each of the records in the file will be sent into a separate location on this same S3 bucket. Well, Minio S3 bucket. So we're going to put that in there in a separate bucket. So, and the events are going to be listened into once the data comes in, and we can use that on our Kafka, just like I explained in the architecture earlier. So let's go in here and start putting things into perspective. Okay, so in our buckets, if you go back to this object browser and you go into this, you can create a new path, and maybe I'll call this create a new path. I'll call this NYC taxis file. Okay, so here we need to upload a new file, so I'll just click on the upload and then upload file, and in my data set I'll just highlight everything and upload. Okay, so that will give us access to the yellow trip data. Okay, and you can see we have all of them from 2023 January to 2024 February. Okay, so good, we have the data that we can work with now. So it's time for us to have the code that will be used to fetch this information. So don't forget, the goal is to be able to replicate the AWS service where you have events that are going into a bucket listened into by Lambda. So when you drop something in the bucket, Lambda picks it up and triggers the processing. Okay, so yeah, let's go into the code and get that started. Okay, so we are going to need a Spark master worker architecture here, but for now I think we can focus more on the coding section. So once that is done, we come back, or maybe we should finalize on this. Yeah, I think we should probably finalize on this. If we have the other information that we want to work with, we can do that. Okay, so let's quickly bring in our Spark master worker architecture, and I'll just quickly do a quick pause and play and paste it in here. Okay, now we have our Spark master worker architecture. You can see the Spark master is coming here and the worker is here as well. And the process is simply the same as before that we've been working with in the past. The only difference is this is now having a jobs directory. Okay, so we have a jobs directory here and a jobs directory here as well. So if I start this up, we should be able to see our Spark master worker architecture setup, and the folder for the jobs are automatically created for us. Good. Now we need to get in our producer. So the producer will be the one to read the data from our Minio S3 buckets and read the data from there and start pushing to Kafka. As simple as that. So let's get in our producer. Maybe I should create a new file called producer. I should just create a new one. So I'll say producer.py, and in my producer, this will be the Python file anyway. So we're using the Python now. We've done the upload. We are working on the Python section, so we can stream data directly into our brooms. Okay. So going back to the Python code, we're going to have a couple of installations that will be used. So we're going to be needing the Minio, and we're going to be needing pandas as well. So I'll just say pip install Minio and pandas. Okay. I think we are going to be needing PySpark as well. Maybe not now, but maybe later. So I just want to quickly, do the installation once and for all. Okay, PySpark is installed successfully and other information follows suit. Okay, so let's start using that. So I'll just say import IO. I think it's still indexing the installed packages. So we'll just wait a few seconds for that to be done. So if name equals to main, then we just start the services, and we just do a simple try except and we just print not accept t, it's accept, and we just print error occurred, and the error is simply E. So we're just getting, so the major error that can occur is the S3 error. So S3 error as E. Okay. So let's bring in the dependencies. And we just have a function that will be called, and the function will be main. Okay, so we can now have our function being defined here. Okay, dev main. Now in this main function, what are we trying to do basically is to call the Minio API and read the information from there. But for us to do that programmatically, we need the access keys, right? So going back to the UI here, we need to create an access key. So come here to the access keys. There are no access keys in the system, so let's create one. Create access key, and this will be our access key. So I'll just call this no expiry dates. I'll call this Lakehouse engineering keys. Okay, and create. Now I can copy the keys Okay, I'll just copy this and put that into a file. Maybe I'll put that inside minio config. So I'll say touch minio underscore config.py, and here I'll have config. It's going to be access key. Access key will be this, and secret key will be this. So that's my access key, and my secret key, I'll copy that and then I'll paste this here. Good. Now I have my access key and secret key, so I can bring those in. I can say from minio config import config. All right, so that gives me access to the configuration of access key and secret key. So I can have a client from minio, so which would be minio. I need to import this. So let's import that from minio. Okay. So I think it's a little bit different, so I'll just import this separately. So I'll say from minio import minio, and this is not from here, it's from .error, is it? Yeah, and we have s3 error. Yeah, so it's from error. So the import was wrong before. Okay, so in my main function, I have the minio, and I can have the endpoints here will be localhost 9090, and we have the access key, which is going to be coming from config, and I have the access key as well as the secret key as well. Secret key is going to be config secret key. Okay, then interestingly, we need something here, which is the security. So if you are deploying this on HTTPS, you need to ensure that it's secured, and it might pass in the certificate location and stuff like that. Maybe not, but you just have to make sure it's secure. So the security will be true, but in our case, we're using the HTTP version, so we don't need the security or HTTPS information here. So it's going to be secure, it's going to be false. Okay, so now this gives us access, potentially, hopefully everything is fine, to the minio. So we can just close this up, and we should have the access key saved somewhere. Okay, yeah, so now the access key is enabled, so we can use that to access the buckets in the object store. Okay, so now the next thing we want to do basically is to use this client to start fetching the bucket. So let's say we have objects. It's going to be client.list objects, just like we do for AWS so services. So we have, let's get in the bucket name. The bucket name in this case would be equals to bronze. Okay, and we are listing the bucket name, and we are listing all of the services. So recursive is going to be true. So let's say for object in object, so let's print object. Okay, print obj. Okay, and let's see if this is working. So let's take this for a spin. Python producer, not main, producer.py, and we should be able to see all of the data in there. So it says response code is bad. So we are trying to access 9090 is 9000, not 1990. Okay, and I'll save this again and try it again. Okay, good. So we can see the objects here, even though it's unreadable. But yeah, let's make it readable. Okay, so I think we can do vars here, and we should be able to see all of the objects. Lovely. So you can see that, and if that is not as clear enough, we can have end is going to be a new line here. And if you check this again, yeah, maybe, yeah, like this. And that should give us each line. And you can see each of them has a bucket name, the object name, last modified, and stuff like that. So yeah, this is really nice, and we can use this to present the data we want to do. So let's get in our actual object. So we just get in, let's say we're printing, maybe instead of vars object, we just get in object dot object name. Okay, and we just print this out, and you can see each of the objects name that are here, which is the yellow tree 2023 1 2 3 up to 2024. Good. Now we have the object name that we connect to, and easily we can get the ones that has the NYC taxi files. Okay, so if we say so I'll just change this. So we say if copy that. I'll just copy this, and yeah, in this object name, I'll just say URL. It's going to be client dot get pre-signed URL, just like you have it for AWS as well. You have the get request, and we get the bucket name, then the object dot obj dot object name. So what that means is, let's say we want to get this, read the first packet here. So we get this packet, and we get a pre-signed URL, and pre-signed URL gives you access to a particular file for a duration of time. So let's say you have a 1 hour for your pre-signed URL. After the 1 hour, the URL will no longer be accessible to whoever has it. So that may be a security prevention or protection for your files on S3 bucket. So you might want to check that out in the documentation, whether on S3 or on Minio object store. Okay. So the time, which is going to be the expiry date, is going to be the time delta, and going to be 1 hour. So let's put it as 1 hour. Hours equals to 1 hour. Okay. So let's bring this in from datetime dot time delta. Good. Now that we have the URL, we can use pandas to read this particular URL and say PD. Where am I importing pandas? Nope. Import pandas as PD. Okay. Pandas as PD, and I have PD dot read parquet, and we are reading the URL. Okay, as usual, just like we used to do it with pandas and S3 buckets, and the URL, the usual URL for parquet, CSV, JSON, and the rest like that. So I'm reading the parquet from here, and maybe I'll call this data, and we say if the client, if not client, bucket exists. So if the bucket doesn't exist, what should we do? So let's create a new bucket. But if it exists, so here maybe we need to move this up. Yeah. I don't really need to create a new bucket because the bucket already exists, isn't it? So yeah, there's no need to create a separate bucket for that. But let's see, let's continue and read the file. So we just say for index row in data dot iter rows. This is pure pandas, working with pandas. Okay, and we have the row information, so which we can maybe just read the first record. So I'll just break this. Let's see what that looks like. So we just break this break. So we just read the first record from there, and we just say print row and break. So we look at the structure of the data. Okay, so let's run this and see what that looks like in actual sense. It says we need a pi arrow. Yeah, so we just do pip install pyro and fast parquet. Okay, so the installation is done. Let's run this again, the producer, and we should be able to read the parquet and the first record, which is the 2023 January from there. It's about 3 million records, so yeah. And you can see what that looks like. So we have the vendor ID as this, another information as presented as it is. So that makes sense. So what we have is exactly the same way we had it on our Athena when we crawled, but we haven't really started listening for events on S3, right? On this Minio object store. So let's quickly proceed so we can start sending data into our Kafka, and we can now start listening for events. Okay, so right now we have our row and we can extract our vendor ID. Vendor ID is going to be str row, and we get the vendor ID. Okay, which is what we have here. And based on that, we have the pickup date time. And the reason for that is I want to use this to create a file name that will be used to save the record. Okay, str, we have the row, and I'll just get the tpep pickup data. Okay, pickup date time, and maybe pickup date time, that will give me something like this. But I need to format this, isn't it? So I'll just get this and format that. Formatted, it's going to be pickup date time, then I'll replace all full columns with dash, and all spaces, let me see, they'll replace all spaces with underscore. Okay, so that will give me something like spaces here, and the full column will be changing to dash or hyphen. Okay, yeah, that's the simple transformation that I want to do there, and I can create a file name based on this and call this trip, get the vendor ID, and I get the pickup date time formatted, and that would be .json. So if you like, you can write this as Parquet as well, or CSV or JSON, doesn't really matter. I think JSON is a little bit heavy in terms of the size as compared to other file versions, so that is something. But let's just use JSON as for sample sake. So if you want to change the format, you can always use a different format in this case. Okay, so I'll just do record. It's going to be row.to.json. So we just convert that to JSON, and we can just get the because we are streaming to the object store now, we have the record bytes. Record byte is going to be record.encode, and that will be UTF-8. Record stream is going to be io.bytes io, and we read the record bytes. So we can read the record directly, and we can get the stream length, so we can write it to the bucket directly. So we have the record stream length. It's going to be length of record bytes. As simple as that. Record bytes. Okay. Now we can say client.put object, and we can now do a put request into the bucket. So as simple as that. So we just have the bucket name is going to be so here I think we might need to create a new, so I don't want to put it inside this I don't want to put it inside the bronze same path. Maybe I'll just create a new path. I call this NYC taxi records. So we have all the records, individual records in there. So I'll just copy this. So if the folder does not exist, I can just create that. So what I'll put this and upload a simple file into that. Yeah, I'll just keep that here and I'll delete it much later once that is done. So yeah, coming back here, I'll just say the bucket name is going to be this. So this is where I'm putting it into. That will be the location where the data will be sitting in. Or maybe I should even create a separate bucket for that. So let's just do that. I was lazy to create a bucket, so I'll call this NYC taxis record. Okay, invalid bucket name, NYC's taxi record. Okay, I'll create the bucket. So now this is the bucket name. Good. And we can go back here and put this as the bucket name. Now inside the file, the object browser here, I can create a new path and call this taxi record. Okay, and just upload a simple image file. So once that is uploaded, now I have the taxi record and I have the file here. So I can upload the file directly into that location, and I can have maybe something like this and have NYC taxi record, and I put in the file name. Now for the content, what the contents look like. So the content is going to be the record stream, which is this guy, the streaming, because we are streaming directly into the bucket. So we are going to have data is going to be record stream, and the length is going to be record stream length. The content type is going to be application JSON. Okay, application /JSON. Okay, and this will stream the data into the bucket. Okay, good. Now that that is taken care of, we just need to maybe print and say uploaded file name to Minio. Okay, as simple as that. We'll just do a quick break so we can check if the file gets uploaded, and if not, we can fix it, and we can, before we move into the full-blown streaming. Okay, so let's check this and see if the first record, which is this guy, if it gets saved into Minio. Okay, let's check the producer again. Okay, it's reading the data. I think once that is done, it should start streaming it. So while that is going on, let's check this out. In the taxi record, let's do a refresh. You can see, lovely, we have the file that has just been uploaded, and this is for January. This is 2020. This is the vendor ID and the date, the time as well, which is good. So you can see that the file got uploaded to Minio. Good. So right now we need to now take care of the Lambda events, or the events. Yeah, Lambda events, or whatever you want to call it, to listen to events so we can start producing data to Kafka as the data is getting sent into AWS. Minio. Yeah, they're kind of dropping replacement. So yeah, it's expected. Yeah. So going back here, we have our Minio here, simple as that. And we can have, what's it called? Yep. So we can unbreak this and let's go full-blown mode now. Before that, before we do that, let's do one more thing, so we can be double sure that everything is working as expected. So coming back here, we come to the events. Okay, we don't have a destination or any link here, so we can do that here, just like in S3. If you don't forget, in our S3 we have a link from S3 bucket to Lambda, or you can do the link from Lambda to M3 to S3, right? So it doesn't matter where you do it from. The process is simply the same. So if you decide to go from the S3 route, so it will create a Lambda function link to your Lambda function, or it goes from Lambda to S3. Yeah, so let's just go from S3 in this case. Maybe I can demonstrate how it is done from Lambda as well, which is this event, to the object storage. Okay, so in our object buckets, if you click on the buckets here, we have the NYC taxes record. If I can only read that. Yeah, I have the events here, and I'm going to be subscribing to events. So we need an ARN here, which is more like the objects that we want to subscribe to, and we don't have that until we come to this event and we create a destination here. So we had an event destination. So the event destination that is currently supported out of the box is Kafka, AMQP, MQTT, and the rest of that. So I'll be selecting Kafka in this case, and I'll call this maybe taxi trip sync, and the broker will be broker 1299092 and broker 2299092. If you are unsure of that, you can get that information in your Docker Compose. So you can easily copy from here, which is the two guys that are here. So we are listening for in the control center. This is the one that is connecting the two Bootstrap servers, our brokers, together, that are in the same quorum. So this is what is connecting them together. So we are using the brokers in this case. And this topic we want to use in NYC trip records. So if you have a Kafka broker or that is on the cloud, you need to use the SASL username and password, the mechanism, and the way to connect, which is the TLS authentication method. And that's for SASL. If you are using TLS, you need to use this TLS details here. Okay, but we don't have, luckily for us, we don't have any security on our brokers that is running in the quorum, so anybody can have access to it. Well, only me can have access to it, so because it's on my local system. Yeah, so we use that as our Kafka event destination, and we just save that. Now once that is saved, we need to restart. So this is just a restart on the UI to just trigger the restart. It's not the entire system restart. Okay, so once that is done, the restart takes about a couple seconds, maybe 1 or 2 seconds, and that's done. Right now you have Kafka trip sync that is here, and you can confirm that on the UI. If you go to where's our topics here, potentially if you look at the topics, that should create a topic for us by the time we start producing data into this. If you like, you can create a topic by yourself and give it the number of partitions that you want, or if you like it to be created on the fly, that will be done automatically as well. So coming back here, I have my producer that is going to be producing records, but before that is done, so let's see if we run this again, if the data gets produced. But we already have a file on our S3 in our S3 bucket, so we just delete that file. Yeah, in the objects browser, S3 bucket NYC taxi record, and we just delete this particular file. So this is the one we use to test again. So we just need to upload this again into our Kafka and see if, oh no, I'll stop this. Yeah, I missed one more step. There's one final step that you need to do. So in here, we now object. If you look at the bucket here in the administrator section, if you click on this object, you need to subscribe to this event, because we just created the event that is connecting to, more like you have a Lambda, but there's no association between the object store, which is your S3, the buckets that you created, and your Lambda. There's no relationship. We have S3, we have Lambda, but there's no relationship between them right now. So let's create a relationship, and that's down by clicking on the subscribe to events. So right now the ARN here is the trip sync for the Kafka. So this is using the queue service as expected. So the prefix is simply, we just leave it as prefix. So if you can recall, in our earlier version of this video, we have the the file name as a filter. That would be the prefix in this case. But in our case, we are looking at the put object, which is the file that is uploaded into the system. Luckily for us, we don't have maybe different version of put event, so anything that gets uploaded into the system gets picked up. So yeah, I'll save that, and right now this event has been associated with this bucket. So any events that happen here will be triggered and sent to this particular topic. So let's see how that goes and run this again. Okay, so the producer is trying to produce a single record this time around, and let's see how that looks like. Good, uploaded that. So this is uploaded. Let's verify the upload, and in the objects browser we can go to this guy and see the file has been uploaded. Now let's go into our topics and do a refresh. Can we see the topic created and the file? Lovely. So you can see if you click on the topic and click on the messages, you can see the data that is produced to this topic. And if you start from the offset of 0, jump to offset, and okay, there's nothing in the topic. That is strange. But let's see in our in our broker here. Let's see what's going on. So we have Kafka topics, and we have list, and we have bootstrap servers. Bootstrap server is to broker 129092, and we should see the list of topic. Good. And you can see the NYC trips record. So if we start from the beginning, and so instead of that, we have Kafka console consumer, and we have the topic is going to be this, and our bootstrap server is going to be broker 129092, and we're starting from the beginning. Beginning. If I can only type from beginning, that would, yeah, you can see the record here. So interestingly, I don't know why on the UI this is not getting picked up. So let's type in 0. Oh yeah, I need to type in the partition. I thought the partition would automatically be listed, and that's exactly what we have in here. And interestingly, you can see we have the event name, which is S3 objects created for the put event, and you can see the key is here, and the record information is here as well. Okay, so yeah, so we can pick this up and you know, dissect it as we like on Kafka. Now that we've successfully written data into Kafka and everything is working as expected, the second bit is done, and you can see in the architecture what this looks like. So we are technically done with this part. We've produced data var upload, and we've also done the var streaming. So these are just demonstration, so you can plug in actual data sources from here. So we have a bronze storage, which is AWS, well, events is listening to events that are going into this bronze storage and producing data into Kafka. We are able to visualize this on the control center, and the schema registry hasn't really done so much in this case. We're going to come back to this much later, but for now you can think of this as pending. Okay, so we have our data sitting pretty nicely on KRaft mode, and we have all our brokers here serving as both controller and the broker. So in the next bit, we are going to go into having Apache Spark and Apache Flink as our data consumer. So these consumers will be, one of them will be real-time streaming, the other one will be batch streaming. Unless we want to use Apache Spark for both or Apache Flink for both, it doesn't really matter. They can really serve the same purpose. It's just you know, macro batching and all that is a little bit different, but in this case it's not really nothing too serious, so we can use either of them for our use case. So yeah, those are the two things that is going next. So we're going to be having different connectors to Elasticsearch, to Slack, and to Cassandra, and we're going to be writing information back to the silver layer and the gold layer eventually. So yeah, let's stick to that, and in the next video we're going to be picking that up. Thank you very much for watching, and see you there.